Welcome everyone. Welcome to the best practices and tools for high performance computing and Andrew's series of training events, episode 2. We had the first event in last January. My name is Tanya Pushpadas. I am the course coordinator at Andrews. And before we start today's episode, Advanced Shell Scripting and Utilities, Part 1, I would like to give you some logistic and practical information. First of all, Andres, who are we? We are a collaboration of four largest universities in Norway, University of Bergen, Oslo, Tromsø, and NTNU in Trondheim, together with public company Sigma 2, which manages the national infrastructure services. So this collaboration is called NRIS, as for Norwegian Research Infrastructure Services. We collaboratively operate all the national infrastructure services. So this training is part of our NRIS training and outreach program. Here together with me, we have our instructor and helpers. I will come to you later about that, but a bit more on the logistic part. As you can see, I'm recording this event, so please feel free to switch off your cameras so that when we edit this recorded session, it's been easier for us. Anyway, if there is something from the user side, we will be editing that. As you can see, I have put it on the chat as well as you got the email about the collaborative document that we use that Ule is sharing now, the best practices tools for HPC episode 2, that one. This is the one we will use for questions and answers. Please use it. There is some icebreaker questions for you to answer. Go ahead and answer it. And please remind that this is shared. When we record it, will be available publicly. So don't use any personal information there. Use it as maximum as anonymous. No names or numbers or anything, please. Other thing is we follow the Carpentries Code of Conduct. So we are many people here. Please remind to be using respectful language while you ask or answer the questions here. So in this document, you can see that the recorded version of our previous training is linked on top of the document, as well as the upcoming events. So when we prepared these shell scripts and utilities, we thought this will be going to be a one event, but when we prepared the material, it was beyond 2-hour session. So there will be an episode 4, which is the follow-up of this episode. You can register for this. You could find the registration and details for the on the course web page. And this is mostly advanced shell script, so you don't need to use any high performance computer, but you can use any terminal if any Unix like operating system. So you use it terminal, or and then whatever Ule is showing that you could do it on your own computer or laptop. The lesson material that we use for teaching today will be up to, it is linked to the top of the page. Ule, can you move a little bit further up so that we show that lesson material? Yes, that is linked there. You could review that, refer that also when you learn, and after this course, this will be open. Without much further ado, I would like to introduce our instructors, and we have some helpers from Enris as well as our friends in Alto. I guess Enrico is there. So Ule, would you like to introduce yourself and then move to Maikin and Enrico?
Yeah, Ole, University of Oslo. I've been using Linux for a considerable number of years, but I don't have an IT background. So the things I learned the hard way. I needed to learn it. Just like math, I know some math, and that's the part I've been forced to learn. So same goes for this, but I've been using shell for quite some time. I saw somebody put up Z shell, but today it's mostly bash, and there later on there are links that you can click on to see the market share of the different shells, and bash is the overall mostly used. So, Maiken.
Yes, I am at the University of Oslo with Ole, and I'll be helping in the background, trying to help you with questions that you write in the this collaborative document. And I have background in physics, so I also learned the hard way. Yes.
Yes, Enrico, would you like to introduce yourself?
Yes, thank you, Dania.
Yes.
And I'm Enrico Glerian from Aalto University. And my work, we support the people of our cluster, the Triton cluster, but we also help people in the national cluster CSC. And so we'll make sure that also the people from Aalto can run the examples on our cluster.
Thank you so much for joining, Enrico. Highly appreciate your participation here. And I remember that I mentioned before, I forgot to mention that I'm from University of Bergen and work collaboratively at Trendris. When Ule and Maiken was mentioning them, then I remember, oh yeah, I have to. But so without much delay, Ule, shall we start? You want to say something?
Yeah, no, we'll just start off.
Yeah. There is an icebreaker question and a poll just to find your shell. So if you can go to the collaborative document.
Yes.
Yes.
I cannot guarantee that the Z shell works as expected. So yeah.
Yes, great.
Bash, everything I have, all commands I'll put into the tutorial text are cut and pasted from a terminal working, so I know they are working, but I'm not too happy about. I can guarantee that any other shell works the same way. There are subtle small differences in these different shells, so yeah. So having said that, we'll go on. Yeah. The shell in Unix is a complicated thing. I normally ask people to read the man page, but if you issue the command man bash, it's 3,800 lines long, so no way. It's a complicated thing. I don't have time to cover everything, but I'll go through most of it. We can start with the input and output devices, because you probably redirected, because that's part of the basic training and the onboarding, that you can redirect by using a larger and greater than sign and so on. And then you are probably exposed to the number 2 to redirect errors to the standard, to the deb 0 and so on, deb null, so you don't see them. And just to show you how this is built up, you see that if you do ls minus l on the dev std, you see that there are standard error, standard in, and dev standard out are also symlinks to the process yourself and file descriptor number 2, 1, and 0 and 1. So everything like you think of devices in Linux are actually files. So there is no concept of devices here. There are files, they are file mapped, everything, and the file could be memory mapped also. So Unix is fairly easy in that way. Everything is a file. And we'll see that you can say hello world and then go to the standard out, and you can punch it to go to standard error. But an interesting thing is to run the cat function to standard in. So anything I print here, when I push enter, it will be sent from the keyboard to the standard in, and of course it will be echoed. So if I now safely, you do a control C, I could have taken Control D, but I'm afraid I've been logged out of my shell, so that takes down the whole terminal. So Control D is end of file marker, and we'll make this a little bit smaller again. The problem is that there's not an unlimited amount of space. So one thing, message to take home for this one is that if you have a program that print out a whole bunch of errors and you don't really want to see the error messages, you can redirect the standard error, which is symlink to device 2 to devnull, and it will be gone. You don't see it. More important, that this is one of the things that you actually need to know is that escape characters, so that you don't really need to well, you escape the characters, so their meaning will be taken away, because the shell is normally trying to make sense of what you write on the command line. So the command I just said, echo backslash quotation mark, will force the shell not to deal with the character that follows behind it. It will print it literally. So if I press enter, it will just echo the quotation mark. So this is very important when we are writing scripts or regex or etc., so that they will not be eaten by or interpreted by the terminal or no, by the command, by bash. So if I say echo host name, of course it echoes my host name on my office computer. But if I use single quotes, not double quote, if I use single quotes, it will not echo the same string. So this is an important thing. If you want your command to be expanded by the shell, you use double quotes. If you want to echo or use the string literally without any interpretation of bash, use single quotes. Things that can be very important. We skip the JSON code because if I go deep into that, people say, why don't you just say import JSON in Python? Yes, I could, but this was written for a controller which was impossible to run. This is C code on an Arduino that they are not too happy with Python. So that's just to see how you can see how you deal with with all these escaping characters. It's also important that if you try to, if you want to run on a different computer, you say here, it's not too happy with the ls home. But if I use single, it will print out the ls. So this is sometimes it will keep the string literally, and then that $home will be forwarded to the other computer, and you will actually see the ls of the home. And of course,
Maiken has something to ask.
Maiken.
Yeah, no, I was just thinking that for the people, don't be shy, use the collaborative document anytime. If you have questions to what Ole says, write your question and we will answer it ongoing. So anything, if something is unclear, just hammer out your questions and we're here to answer them. Hopefully.
Thank you. The same feelings here. And Ole, I have one question to you. Do you expect the participants to follow this, or while you try it on the terminal, what do you suggest them?
That's up to their if they want to try them again, but they're also happy to follow on, and because I'm going to type most of the things, or they can play with it at home or try to type along. But I mean, I'm not too happy with type along because this is easy, because if you miss a step here, you're good to go for the next step. But if you are, let's say, in a Julia training when I was, if you missed one step, you were lost because everything was building up to a big program. So up to you. If you like to continue to type along, it's fine. If not, then yeah. Yeah. One important thing with the escape character is that here you see this is something that you very often see in make files and such. The string would be more than one page, one line long, and you want to break it into several pieces. After this backslash here, there is a line feed character. And if you escape the line feed character, there is just a single string without the line feed. That's why when you run this command, this is a bit tricky, because if I include a space after, it will escape the space and not the line feed character. So make sure that there are no spaces after the escape character. If there is a space, then of course that space will be printed out, and then the line feed, and then something strange happened, because then it will break the line. So make sure that you hit enter straight after issuing the backslash. Then we skip the one that you can go this here, touching files and such. We'll come on this later. This is something that you'll normally set in a script or a Slurm file to X if you want to echo the command exactly as they are executed. V for verbose, it will print out some information. The two most important one that I suggest you use, especially in Slurm script, is to set the -echo, -e for echo, is exit on any error. If some of the commands in the Slurm script returns something else than 0, it will exit the whole thing. Same if you are unset variables. So if I say now echo, I know that this is not unset because I set it to echo 1. But if I say I said return echo 1, but if I now say echo $? I get the return value from the echo process. But if I say unset A, echo A, it's still 0 because it's unset. But it will the error, the -u, will exit on unset variables. But I have deliberately not set -u here because we are going to play with set and unset variables all along. But if you want to make sure that it exits if a variable is not set, it's fine. Yep. If you want to fire up, then you can use plus instead of minus and such to change it back. I'm not sure how much they covered in the onboarding, but we have the history buffer in shell. History with a long list of things. So if I want to say, there are ways of searching also, we'll come to that later. 109, that will be the echo $1. Yeah, that will issue that command. I can also say Control R, that's further down, echo A. So be slightly careful, or be careful with the with the exclamation mark and N, make sure that you are confident that you are not doing something you shouldn't, because if you just do like this, double, it takes the last command. But if you screw up like 1, 4, and 8, that might be a different command, fortunately enough, but it could be an RM command. So be a bit careful with this. I have colleagues in Bergen that say I shouldn't show the users this, but sooner or later they will figure it out anyway. So better now to caution you that it's a very powerful tool, but it can backfire. If you are unlucky, it can issue some command you didn't want to issue. Okay. We go on to command line edit. If I print something, some characters, I can use Control A, I can use Control E, and I can kill, I can yank, I can set mark, I can kill from cursor to mark, I can yank, I can undo, etc. I can undo and so on. I can search backwards. I need to say that these are Emacs bindings. So the same command that you find in Emacs will apply to the command line. But of course, it's possible to change to VI if you prefer that. I'm not going to show you how to do it because I suggest most people either use Emacs binding, but it's possible to change the binding. But there is only two choices in Bash. There is Emacs or VI. Then you can encapsulate shell commands by, we set A to high, and then we can echo the outcome. If I say we all know what happened now, nothing special with that. But if I say this, it will echo the outcome of that function. Of course, that's A. If I put in the $A, it will be this one. So differently. I can also say PWD here, because that's the output of that command. That will print out my working directory. But of course, there's nothing to stopping me from setting like this. So there it is. And it's possible to make functions in the shell. Not mostly if you want to write shell script, but it could be that you wanted to write some kind of function that you often use. During a session, you can write the function and then you can just issue the function. Hello world. So yeah, you could even make a one-liner, because we are not going to make shell scripts in this session. We are going to make one-liners. We can say, oh, well, yeah. The $1 is argument number 1. We can have 2 arguments if you like. You can have as many as you like. So that's the born again shell. So we'll jump over to shell variables because we don't have all the time in the world here. Any issues and questions so far? No.
No, we are answering on live, Ole.
Yeah, yeah.
Thanks.
There are 2 kinds of variables. They are identical more or less. And of course, it's possible to promote all variables to be environment variables, but I'm not saying that's a good idea. There are the shell variables. They are local. Then there are environment variables that are global. But of course, they are not global in a global sense. They are only available in daughter shells. They cannot go upwards on the parent shell or grandfather shell or grandmother shells. They go only one way. So if I have a variable, then if I put it to like an environment variable, then it's valid for all shells started. So it will be all there. So if you look for environment variables, you'll see that looks like they are everywhere because most of them are set when you log in. Using the keyboard export will cause the shell variable to be inherited by child shells, but we'll have more on this later. We can declare a variable. I've already done it for you in one. We can say A equals hello world. It can the names is more or less the same as valid letters in valid identifiers in C. So not every character is allowed, but that you need to look up. But for the most thing, it's the letters and numbers are okay. If you avoid the special characters, you should be good to go. So I set A to hello world, but there is no price to be given to know what's going to happen. The $sign is needed to inform the shell that this is a shell variable or an environment variable. So echo A will, of course, just give A. Echo $A will give hello world. So that's how you identify that this is a shell variable. We also have putting things together. Now we are in a territory where you could be in trouble. If I say now echo AA, of course that will echo my file, and the dot is one of those characters that can be used as a separator. If I say something like this, it will take the text here and append after the dot. So we can do others. We can say 1 and 2. We can see if we are trying the underscore. And for those of you who have been programming, you know that underscore is a legal character in identifier name, at least in C. And you see here, it says that A underscore B is a single variable. So the underscore is not allowed as a separator. But of course, if I try to set it at like this, it will only be 2 because A underscore is a valid name and A dot underscore is not set to anything. So the underscore is valid. So but then the safe option is to use curly brackets. If you want to play it safe, if you have combined things, or some people always use curly brackets. I am lazy, so I don't like to use the curly brackets all the time. But I have colleagues that use the curly brackets all the time. So as we saw with the examples above, it's not totally trivial how to put it together by using the separating characters. So we can now look on these examples here where we use the curly brackets around each variable to be sure that they are separated. Yeah. They are, and we can make D even more. We can put in we can put in blank here, and that will be seen. So if you use curly brackets, you are fairly safe. So if you want to make something like this, always use curly brackets. If you just want to say echo, there's no need for curly brackets because it will be exactly the same. But be careful when you do combined or complex structures, then always use curly brackets because it's so easy to make mistakes. I put in the allowed characters that could be used for separating, and it's dot, comma, slash, and colon also. Be careful with those here. They are not to be trusted. So use curly brackets. I mean, even though they are allowed, be careful. The slash is an interesting one because you can have as many as you like. I mean, this one is an interesting one. You can have one is equal to many. So if you are faced with where sometimes you end up with a lot of these, don't bother. You can have many of them. So, yeah, you get what you asked for. So we can take this example here again. You can say myfile.extension, easy, but be careful here. Here I would suggest using curly brackets. But if you say plus extension, you get the plus sign. There is no concatenation of strings. You get what you asked for. The plus sign is just a literal one, so it's allowed as a separator. So it's going to be just separating. So it's not read, it's not interpreted by the command, by the command line editor, and then you get the plus sign. So I have a little caution here. While easy to write, the syntax is prone to errors. So use curly bracket for anything but the simplest stuff. So any comments or questions so far?
There was one question that came now. I don't know if there's a comprehensive answer for it, but the curly bracket and the square bracket. I know that square brackets are typically used for if tests, maybe they're used for other things. And so the difference between the curly brackets and the square brackets.
We'll come to the square bracket. They are mostly used for if tests. So curly brackets are for the variables.
Yeah.
Yep. So we are to use the unset. Unset doesn't take a dollar sign, it's just a name. But we'll see echo $A, my file. Unset. I'm also using the arrow up because I'm lazy. You can use the arrows also up and down, just like in Emacs, or if you have VI settings, it will be the same. So now A is not set because I've unset it. So to unset a variable, use unset. But we now want to say that, just to make sure, unset B, I could have played around for some days ago with that. And then now we set C to the def, since B is not set, then C should be the default value. If B already set, then equals look what happened then. Then it's set to user. So if you want to update or to have a variable that if not set when you enter your script or write or need it, then use the default setting. And then set only if not set. This is using there are very minor differences in if you use dash or if you use the equal sign. It's dealing with most if it's set to 0 or something. So it's not really that you need to pay too much attention. If you like to use the equal, use the equal. If you like the dash to point at, then no big deal. Most of the time, it will not be any difference. If you notice difference, then you need to read up on what's exactly happened. There's a link that you can put to. So mostly if the variable is set to null and something like that. So yeah. Yeah. You can unset all to flag all unset variables are set to U. So that's another way of dealing with it. But to do the default value is a nice thing. Then, so while I covered this quite easily, this is a piece of quite important information to convey. So that should be on your cheat sheet. We discussed before we started that we should produce a cheat sheet so that you have only one page that you can use as a reference. So check if a variable is set. We unset E to make sure. And then, yep. We get an error. And then we also get error here. But E is set. So we can easily check if a variable is set. We can also set it to nothing, which is interesting. So even though here are the things that comes in if a variable is 0 or something, because an empty string is also interesting. It's also flagged. But a blank is different. Of course, it shows nothing. So you can you need to play around with this to get a feeling on it, because the Rome wasn't built in one day. But I mean, how do the young teenagers are so good at the phone? Because they spend so many hours playing with it. So the same applies here. You need to spend time to learn how to deal with this. So now we learn how to check if a variable is set, and then later on we'll know what to do to take action if it's not set. Then we can list all variables. If it started on some character, we can say echo the load library path. I didn't have put anything in the first A, so it showed up, but it was the A equals hello. And I say it will print out A. So, but something like this, the load library path is interesting, because you can get hold of instead of writing library path, you can use short terms like this. Most of the things will not interfere. So, but be careful with such wildcards, because it's possible to get the wrong thing here. It could be something else. And if you are using the RM command with this or any other, you could screw up. So be careful. Then we have the scope of the variables. So if I say A equals local, I export B to be inherited, and I echo A and B. Local inherited, of course. But if I open a new shell, bash, and I issue the same command, it shouldn't. This is interesting. I might have exported A. Something is not right here. Could very well be a demo effect. Right. A was exported. Now you see that when we echo that into the bash, it will not be echoed. So an exported variable is available in as a child shell, child process, but not local variables. So the G is not exported, hence it's not available in an extra shell. So scope of variables, it can be quite interesting. I see if we do env grep A. Oh no, that doesn't work. We need to have a more elaborate grep for that. So yeah. But we could say export. No. Yeah. Anyway, the point was G is local and not visible in the bash shell, in the subshell or child shell. We can list all variables, which it's from time to time very important. But if we do the end, it will print out a lot. But it will only print out the exported variables. So if we using I think head and tail should be covered in the onboarding. If we do this, you'll see that there are some variables, and all of those are environment variables. The variables that are local, they are not visible in the end. So yeah. Before we go to the altering of variables, is there any comments or questions?
You have answered the questions, but I would like to emphasize that more questions are welcome. So please use the collaborative document if you have any questions or any comments.
Yep. When do you suggest a break?
After 15 minutes.
Yeah, 11 o'clock?
Yes.
Yeah, fine. Okay, altering variables. We say, of course, this is easy. But now we use curly brackets. We say the variable E, and then we use the hat or power function or whatever you like to call it. And now this is part of the magic. I mean, well, it's not magic, but this is some of these tricks that you couldn't figure out in an easy way yourself. This is something that you have to learn and write down and keep in mind that it's possible to do. And every 26th year, you might need actually this. Then you look up the cheat sheet. This is how you do it. So, because it's, unless you sit down and write shell every day, this is not something that you remember by the top of your head. So it capitalized. So this is a nice one. But we can also do all the letters in uppercase, like this. And of course, we can say that F equals, and this one we already learned. Right? Now we can say echo F. We need the curly brackets again. So the curly brackets is your friend. Never leave home without them. Right? We lowercase the first character. But of course, there's no prize given for figuring out what happened now. So this can be very handy to change the capitalization of the or upper and lower. That's the easy part. Now I think Albert is so popular in natural science because of Albert Einstein. And now we are changing the R in lowercase. We can do the same with the B in lowercase. We can do the same in uppercase, only the B. Then there's not much theory to tell you behind just explaining it and showing to you. So we can extracting part of a variable. Now we are doing something that is position based. You see, we are doing here. We are doing it by position. Positions are a bit conceiving because if things changes and so on, it's not adaptable to changes. So position based could be dangerous, but it's also very powerful. We print out the first three characters. So 0, start from 0 and number and three characters. We can say 5 and then 3 and so on. So we can extract exactly what we like, but we can also do it from the end. So the minus sign can be used in a clever way. I mean, the people who made these things are quite clever. So using minus could be interesting because it starts counting from the back. So that's an easy part. Then we are match and strip. You see here, I made a string where I have slashes, forward slashes to separate the words. And then we did something strange like this, a hash and star and backslash. It will strip the first matching slash. And we can strip from the last matching, but with 2 hashes. Then we get the fox. So powerful functions, but they need, if you really need them, then there's a lot of things you can do with them, but then you need to do some lookups on some tutorials that go into depth with each one of those, so you can see all the corner cases and all the things that it can do. My point is here is just showing some simple examples, and for those of you who really need a deeper insight of this could learn more.
Ole,
Yes.
could you explain a little bit about each of these characters, so the star and the hash, and what each of them does?
Yeah, the double hash are for matching from forward and backwards, and the star is any characters and so on. So like this will only take away the first and the second and the last one. So you need to play around with this to remove them. So you see, yeah, you need the star to take to do. So yeah, I don't really know how to say more than this is how it works. The star is matching all characters. So and the double hash I count from backwards, and the forward start from count from the single one is counting from the beginning.
Can I ask you, Ole, that
Yeah.
double hash, is it going to remove everything up to the forward slash?
Yeah, yes.
Mm.
That you see, it took away the quick brown fox, but not the fox. It stopped just before. It took everything up until the last, counting from backwards. So everything from the beginning to the last one, and then it prints out what's left.
So if you
Like this.
wanted to have something in the middle, you would have to combine this.
I think you need to be, yeah, that I haven't played around. I haven't figured that one out.
Maybe you could start with one part and then keep, using the front and back and so on.
Yeah, something like that. I haven't really tried that, of course, but there's nothing stopping you from piping this into something even more. Yeah. That's the homework.
Yeah, I would use it mostly for removing a prefix in a path or something. That is one use case I could say.
Exactly. Either removing the whole path and ending up with the last file name, or removing a prefix. Yeah, exactly.
Yeah. But then we can get the length, which uses only the only hash sign. It will print out the length.
So it has several
It has several interpretations, yes.
Oh, okay.
So it's not easy.
So we should maybe Google a bit what all.
Yeah, you need to look into a tutorial. Because
what all meanings.
Yeah, there are many meanings. So yeah, it's as I said, the Bash manual is 3,800 lines long, and I am only capable of scratching the surface. So yeah, I put together some examples here to tease you with that. You can dig that deeper down if you really want to come up with some clever usage, like removing the slashes and so on, and the path, and you only need the file. If you have a very long file name, like this, if I say, and then now here, and then took away everything up until like this. This is what you thought of, Mike, and I expect.
Yeah, for example.
Yeah, which an example to get only the file name. Let's say if you say which ls, use a pin ls. And then if you want only the program name, you can use this one. Yep. We could spend the rest of the day playing with that. Wait until we get to the regex. We could spend the rest of our life. So it's, I say, exchange and changed. I mean, there is no end to what kind of complicated stuff you can put together. So here I made a one-liner just to illustrate that you can make a loop. Now we use the Emacs editing on a command line. We say go like this, and then we yank the one we had. Here I set y to 2. And we'll cover more on loops later on, but this is just to show that you can make a very complicated stuff. I have make a sequence going from 0 to the length of a, but I subtract 2 because we are, as being obvious, we'll see why I do that. And then I print out a few interesting things. I capitalize 2 characters. So yeah. So it's possible to combine, and then it could be intimidating to write such things, because this is something that you need to sit down and think, how do I do this? What's happening here? But it's a nice example to sit down with paper and pencil and print out and watch what's going on. Having said that, I think we'll cover more with loop. There is a whole chapter on loops later on. So, but it's possible to make quite complicated stuff. And then it's soon a break, and then questions or comments. Was it too hard? Was it too easy? Or yeah.
Shall we go for a break, Ole?
Yeah, we'll see if there are some comments first, and then we'll take a break.
We can make a poll, maybe.
Yeah.
Did you manage to follow?
Yeah.
Yes. Can you share the collaborative document? Or...
Yeah, I'm just reading the. Question of what does source mean? Yeah, of course, yeah. This is a bit out of this thing, but it's nicely answered.
Welcome back. Ole, shall we continue?
Yes, we continue.
Thank you.
Substitution and so on. This is also something that you need. Yeah. I set animals to dogs, then I don't like that, so I change it to, what did I do wrong? The syntax is important. There shouldn't be any, no, in my example, it wasn't a slash at the end. So you exchange dogs with cat by using slash. If you read all the text I've written in here, all of this came from the early 1970s, where you had an editor called ED, Echo Delta, ed. A lot of things like this, using this kind of syntax, comes from that. So like grep is another eminent, and streaming editor, SED, that we'll cover in just show that it exists and so on. If we have several identical words, we can say then. Yeah, but we can take away all the dogs by, I think, 2 slashes. That means it means global. The 2 slashes means that you take out all ones, everybody. So the 1 slash means just the first existence or first time you meet it, and using 2, it take all of them. So we can do a bit more interesting one that you'll actually probably need to use in Slurm scripts. Input file equals mysimulation.imp. That's your input file to your program. Then we want to exchange out with imp. So you could actually write a.out with and redirect to like this. That would take the input file into the a.out program and redirect the output to the input file.out. So this is a practical way of dealing with it. But I've also, by using encapsulating command and playing a little bit more around, we could say that the output file is it's my simulation, and then I put in a date and give it out. So I just take away the imp and replace it with a date. So this is a very usual way of dealing with the date, by putting you and first the date and the clock and so on, and then +1 for the time zone that we are in Central European time zone. Yeah. By using double parentheses, we can do simple arithmetic with integer numbers. It's using an old thing in the back that's called expression, but that do its integers. But they put this into the shell, so I can do 1 + 2 here. I can even manage to do some tests. So and so on, but we can do multiplication. A times B. We can also do some and each one, and we can do the remainder. If we divide 10 by 3, it gives 9, but then there is 1 left that we need to accommodate as the remainder. So this should be fairly easy to play around with. Sometimes you need this. It came out from the old expression, but the expression could do slightly more. So you can do substring and so on, A and B, but I don't really know how much uses of expression you actually need to do, but now you've seen it, and it could be, if you need to manipulate easy strings, expression can do a little bit of it, but then sed or awk are far more powerful, so you might not need expression. But if you are desperate for floating point numbers, you can use Julia, which is, of course, can do any kind of things. So here I ask you to give me pi, which everybody knows that 4 times the arc is tangent to 1. But I have an even more interesting one, that if you take...
But Ole, you would have to install Julia, of course.
Yeah. But it's just that if you are desperate for floating point number, because dealing with floating point number is very hard on the shell. So Julia is one of the few things that you can actually do. So if you desperately need it, you can use Julia. Of course, Python can also do it, but Julia is more geared towards floating point, like my last example here. But this is not a Julia training, but it's to see if you are desperate for floating point numbers. This is an interesting one. If you raise the square root of -1 to the square root of -1, you get a real number. So this is the power of Julia, that it can deal with complex numbers. But of course, you need Julia installed. Yeah, of course. But it's if you're desperate for floating point numbers. Just to show that the expressions can only deal with integers. It can deal a little bit with strings. But of course, awk can also deal with floating point numbers. So, but that's a whole different story. But we could talk length with this, but we need to continue with loops. It's important to sometimes to go in loops. And this is a slightly more Python syntax, where you iterate. So I'm not sure if this count as loops. It's called more like iterators. So I iterate between 1, 2, and 3, and I print out hello world 1, 2, and 3. But that's fine, but then you have a fixed range that you have to print out. There is a small thing called sequence that gives you 4 numbers in a sequence. There are different ways, so you can have 1 and 3 and 10 and so on. You see it increase by 3. So it's important that the step is in the middle. Like for many others, the step is at the end. So important to remember with sequences, a step is in the middle. So we can make a bit more combined thing, where I say for j in, and then this one would return 1, 2, 3, and I will say echo hello world and the $j, which is the variable j, and done. So this is the syntax of our loop with using this one. We could say echo, but we have covered this one before, that this is the outcome of that command. Yeah. So another example, we can operate on many files. If I say ls.md shell expansion, because the shell can expand for us. If you ever if you ever happen in a situation where you have locked yourself out by, if you unset the variable path, don't do that. But if you, no, we don't have time. But if you unset the variable path and then do ls, ls doesn't work because it can't find bin ls. Sorry. It won't find ls, but echo would work. So same thing. But do not unset the variable path. That's one of the things you shouldn't do. So we can do more interesting things. We can say something like this. If I make a backup copy of all the episode files, you see, I will have a lot of files here called backup. And now they will be here. Yeah. But I didn't print them. I say just echoed the command. So they were not, you see, there's an echo in front of CP here. Otherwise, I will fill up my directory.
Maybe
But-
you can mention actually, Ole, that that's a very good trick for testing commands.
Yes, that's very nice, Michael, that you reminded me of that. Imagine now that if you have something with the RM command here, and then you can see what's going to happen. So putting echo in front of something like this, like I did here, only show you what is normally referred to as dry run, and that you see what's going to happen, but it doesn't happen. So if a lot of bad things show up here, then you would notice and take action. So yeah, putting echo in front of the command is very good.
For example, also if you were copying and you ended up copying onto some file, it would you actually rewrite that file or moving it, to the wrong location and things like that. So yeah, echo,
Yeah.
perfect.
Yep.
Just replace the dangerous command with echo and you see what's going to happen before it happens.
Yeah, that's probably why I put it in here in the first place. So yeah, but they're very good. So then now we are for the first time introduce regular expressions. Regular expression can be very easy and it can be complicated, but we'll cope with the simple one. The shell expansion we just showed is called globbing. So echo star. Just print out all the files. We can limit it to using this expression here in front of here. So this expression, the hat means beginning of line, and the dollar means end of line. So MD has to be at the end of line, 0 has to be on the first line, and then we map either 0, 1, or 2. So this is a range from 1 to 2. And the dot is any character, and the plus is repeat as many times as possible. So we'll say more about regular expressions. But as you see, regular expression can be extremely powerful, but they are also a bit intimidating. But don't bother with the intimidating part. Don't bother to learn it deeply. Just remember that there are a few easy things that you can have. Beginning of line, end of line, and a range. Typical is to have a range of all characters and all numbers and such. So that's most of the things that you need to know. So, yep. And then I have more complex loops here that they are not really that we can. The following are from an OpenMP performance study. That's mean that you can write them more complex, and this is some kind of things that you actually sometimes need to do. So that's left for homework to play with. We continue with tests and decisions. It's possible to come with some questions and comments also, but okay. Testing for numbers. Spelling mistake, who cares? I mean, this is a good example to demonstrate that this is written by humans and not by ChatGPT. It's some utility called test, but that's still exists, but it's not that much used. Now they have putting it using brackets and so on. We said A and B, and then you can run test, and it's 0. If I change to it's 1, the echo, this is the exit value, but it's being put more easy into where you use the brackets, and then you use more human readable syntax, but just to show you that this is where it all started from.
Just
Feel free to
quickly
yeah,
tell
yeah.
what LT and GT means here. If
Less than and greater than. Less than and greater than. And you have EQ for equal.
Did you explain what the dollar question mark means before?
I think so. It's
Yeah,
the exit.
okay.
It's the exit value.
Exactly.
So yeah, but it's
0, everything's okay. 1.
You see, this is
not.
wrong. So we get an exit value of 1, and LT we get a 0. So the exit value, any command will give an exit value. LS will give an exit value of 0. LS Ole, which give 2. This is interesting. Normally you get 1, but exit value 2 are reserved for wrong human input. So any exit value different from 0 signifies something wrong. 2 normally signify user error. 1 equal that something went wrong. Right. Now we set A and 1, A and B to 1 again. And then we have an if test. If, and then it says square bracket, A, so A will expand to 1. And if 1 is greater than 10, greater than 2, then we will echo A is greater than 2, else A is less than 2. So, bummer. What's wrong here? When you get a prompt like that, there is a missing
quote.
A missing quote.
Maybe the quotes are a problem from copy paste. Maybe
Yeah.
you just try to redo them.
We can do simpler. We can say yep. Of course, there are more. As you can see, there is the FI to close the test. Yeah. I didn't copy everything. You see, you need any of these tests are ending with FI. Otherwise, the system wouldn't know when the test, there is no end function here. So here, A is less than 2. A equals 10. A is greater than 2. So if you see something like this prompt is either some kind of quoting or that something is missing, because you can write these over several lines. So it's possible to, you can write it over several times. So I did put in some more elaborate tests, so here and so, so we can say, yeah, this didn't work, yeah, of course. Here's I have an where you can have both else if. Here is an else part, and it's also combined with an if. And we saw that there is, I did, yeah. I thought I accidentally exit a subshell. But this is how it works. And of course, we can use the greater than and less than sign. It's also possible. So that also works. And you can also say with, you can also do it with characters, but characters are a bit more tricky. And if we are using the normal ones with just a single square brackets, there are limiting the things we can do. Of course, they are not equal. And then we can test if they are not equal. But some are more equal than others. Some animals are more equal. Anyway, we can go over to the more advanced syntax. They extended the syntax to be capable of doing a bit more by using double square brackets. If you are lazy like me, I tend to use single brackets, but sometimes you actually need, because here you can compare two strings. So cat is less than dog. So it's easy because the first characters are different, and C comes before D, so it's obviously smaller. So we can, what I did here, I just swapped A and B, greater than. So this is more elaborate. You only need the double bracket for if you are using things like strings and so on. But it's also possible to do and or and so on. And yeah, but that's more for the more advanced and should be guarded as homework, because otherwise we won't finish today. So now we are going to touch upon the streaming editor. The stream editor originated from the ED editor. You can click on the links and read about computer history. But here I'm using sed in the pipelining mode. I echo cat, dog, and horse, and I pipe them into stream. Piping is also a thing in the that was invented because they couldn't fit everything in the memory, so they have to tackle line by line, and then you could have long pipeline one-liners. So this is a typical pipeline one-liner. This is one of the few things that are so genius with Unix is the piping. Right. So we replace cat by pig. Sed takes a nice, is a very nice syntax. S is for substitute. And there are two ways of dealing with it. Fortran and COBOL are known to be very verbose, so you had probably to use the word substitute in full. Unix command line is as short as possible. So S is for substitute and slash is for separating. So the first one, the matching pattern is cat, and that should be replaced by pig. Then we can do even more, which is cat, dog, and horse. Yep. But it will only take the first one. So if we have something like this, cat, cat, dog, horse, you see it will only take the first one. But if we put on global, G for global, it will take both of them. So if you need to take every instances, you need to put on a global. And grep, as you all probably know, G stands for global, RE stands for regular expression, and P for print. So grep comes out of sed in the streaming editor. And then the address pattern don't need to match the same substitution pattern. So we can address lines. We can put a matching on only match lines containing something. So I made a small file called sed1. It should be here, yes. So there are 4 lines, 1, 2, 3, 4. Then I cat this, and this here. We in front of the substitute command, we have a regular expression 1 and 2. So this will match lines containing 1 or 2. Then it substitutes line with ln. You see, it matches the number 1 with the number 1 here. It matches 2 with 2 here, and then apply the substitute command for the matching lines. 3 and 4 are not matched, so they are not substitutes. So this is the matching of each line before you do any kind of operation on the lines. So we could say first, and then I do a little trick. I said n, that only prints the thing that you actually print. If you remove the n, it will print everything. You see, it will print it 2 times. So, but I omit the printing out of the whole thing. So the n only prints the one that you print. Then we match first, then substitute line by ln, and then print out exactly that line to get first. And then we can do third, and then I substitute S with the number 3, and then the third line. But now we are faced with the one that we wanted to. We want only to do the first existence of cat. So we say, and of course 0 line doesn't make sense because it do not exist. So the only way in matching where where the first line containing, where the first one makes any sense is using 0 line. So we see that the first existence of cat here are replaced. Only the one, only the first existence is replaced. This is a bit tricky, but you see cat is with rats, and only the first one. We can take the fourth. Now it will take several. Cat, 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 and then rat, and then cat, yeah, replaced by rat. All up until the fourth. So, yeah. And then we can say that the pattern matching and the substitution doesn't have to match. I mean, here we are matching for cat, and only line containing cats are being dealt with. So dog is rat and line 3. So here I'm using the line 3, only line 3 to be matched. This is something that you need really to play around with a lot of time to be comfortable with. We can, this is easy. We can you see one cat was removed, so I deleted one cat. Here I delete all the cats, because we remember that global took everything, nothing. Yeah, I replaced cat with nothing. And then there is only one cat removed, but here all the cats removed.
And then you end up with the first character being an empty character.
Yeah.
There might be some way of dealing with that too, but.
Oh yeah, the a space character. Yeah.
Mm.
And then there are 2 of them. Yeah. Yeah, removing character. Yeah, stripping them. And set can match line and delete matching lines. We make like this: cat, cat, dog, horse, and then they come on each line. And then we delete the lines containing dog. So this is Z, matching pattern is dog, and D is for delete. So lines containing dog should be deleted. And right, it does.
So this D, it takes the whole line?
Yeah, it removes the whole line.
Cool.
So, and then we can go back to the first one I had. Yeah, we can. And then we can remove line 1 to 1 and 4. Again, a regular expression. 1, 4 either 1 or 4. If I said, I will take everything, because that would be the interval. But if I use comma, it's only 1 and 2. So, but then again, we have the special characters. The special character that we already seen before, as I mentioned earlier, the beginning of the line and end of the line. And now we employ the Unix hierarchy file, which is an interesting little one. But we now, and this time we don't use sed in a pipelining mode. We just give it a file name. This one will match beginning of the line. And this match the end of the line, but there's nothing in between. So what do you expect it will remove? Maiken, see this one for you. What matches beginning of line and end of line combined with nothing in between? Empty lines. So all the blank lines are gone. I mean, it looks like here, but there is a character here, so this part of this line. So it will match the blank lines, empty lines. Remember it looks like it had many blank lines, but they're all gone here. So this is very nice to remove empty lines, blank lines with nothing. And then we can like this, we can delete lines starting on capital R and D, and then the Z2 we had the rats there, because if you remember, it had rat. And then I search for, I map for, or use search for, or match beginning of the line, capital R, that will be this one. All the lines starting with an R at the beginning of the line will be deleted. And of course, you see that it's deleted. Of course, we could remove the cats, but I don't like to remove the cats. I like to remove the dogs. You see, the dogs are gone. So it is another way of dealing with it. Advanced sed is for the next session in later on. So before we go to awk and so on, any questions, comments? Okay.
Maybe you can take it, Ole, with something you predicted. There is a question, any tools to make regex less scary? So we suggested some of the online tools.
Yeah, I read on the online tools. Yeah. So yeah. There are. I was looking for. I had a picture somewhere about the regex, but the regex are extremely powerful, but it's made. They are invented by theoretical mathematicians in the 1950s. So you can imagine how complicated it is when you let the theoretical mathematicians loose on normal, never expecting people like myself. So don't bother to learn too much about it. Just scratch the surface and take just a little piece of it. So that's the message to take home. But it's very nice to know things like A to Z, comma, A to Z. That will match any character, like this one. Or this one will match any number. So this is one of the few things that you actually need to know. And of course, those two in the expressions. But now we are moving on to a whole new territory, awk. Awk with small letters are the application. Awk with capital letter is the programming language. And awk is a programming language per se. It looks like C, but it's not the same thing. So Ah, I thought I had this. Oh, I think it's gone away. Or one file is lost. Doesn't matter because we can easily remake it. And now I use Control D, which means end of file. End of file from the terminal. Yeah. Now we can say this is the, oh, and then we want to print out column 0. We launch awk, and it's always you need to quote and curly brackets, begin, end. These are now the curly brackets signify begin, end as in C, and the curly brackets closes the string. That is the command using to put into awk, so the awk program. So the program contains one line now, print $0. So $0, print all the lines. All the columns, sorry, all the columns and line by line. But if we say 1, we get only the first column. 2, only the second column. 3, only the third column. That's the most common use of awk. Of course, we can put in. And the dollar now means it means column. There's nothing to do with variables anymore. Now we are inside awk, and the dollar sign has a different meaning than in the shell. We can print out in any order. I mean, this is another issue is that we can use the column separator. I'm now introducing yet another little tool called translate characters, TR. It will translate space with the comma. I need to be quoted to be 100% sure. So now we get a file that are comma separated.
Ole, why do you have 3 quotes, single quotes?
There are 1 here to quote the blank. And there are 1 here, 2 here to quote the comma.
Okay.
So here are the space, and these are the comma, and then we go to awk and print. Nothing. Then we get the first column. But this is not the first column. This is all 4 of them. So we need to put in a separator, field separator, comma. Then we get. So this is very powerful. If you have a comma separated value, CSV file, which is comma separated, you can use awk because this is a comma separated file, CSV. And then you can use awk to print out the columns you actually need. So imagine you have a big spreadsheet. You save it to a comma separated value. Then you can use awk to extract exactly what you need. I introduced also the TR command, but that's easy to learn. That also can take regular expressions. So there's no end to what TR can do for you. I mentioned that it looks like C. And of course, I have one little piece here that's a little interesting one. I have some numbers. I have 1.2, 4.0, -3, 3, and 3.1 times to the 8th. Then my awk program starts here. Printf as in C. For those of you who don't know the programming language C, you should at least have some basic knowledge of printf and formatting, because it's often used. S is for string. F is for floating point. I put in some numbers here, which is field width and decimals, but percent F is for float. 3 places and 1 decimal, and percent for formatting, and F for float. 3 decimal places, or 3 decimal numbers, I mean integers. Integer with a leading 0. A float number again. And then a float number with format character D, which is mean that it be in scientific format. So I encourage you to actually learn part of how printf works, because it's everywhere in C, but it's also in awk. So now we get a nicely formatted 1.2, 4.0, -3, integer 3 with leading zeros, a floating point number with 8 places and 1 decimal, and the scientific output. So printf is very nice to get nice formatting. So awk also support printf. So awk support a lot of things, but we don't have time to go through more than this. And of course, advanced Z is for the other. But if you are faced in a situation where you would like to print out line numbers on a file, then awk come to your help. An uninitialized variable is normally set to 0. So this one will start from 0. It is 0 when you start, and when it's used, it's being incremented after use, and we print out the whole line. You see, it gets line numbering. But of course, the first line is number 0. We could move the pluses in front, so it will first increment, then use. Then it should start on 1. Yes. So depending on what you like, starting on 0, starting on 1. I prefer starting on 1. And that concludes this session. The next time we'll cover some more advanced Z and advanced awk, and we also have some Slurm scripts. We have 2 minutes left. I can show you one example. We put in some timing and loops and so on. There should be one that you actually, no, it's on some practical examples. There's one thing I thought might be interesting. If you are programming in Fortran and load a module like GCC, you get the echoes. It won't work because you get C path set to this. This is what the compiler will get you, or the module will print out. The module will set C path to this, which the include path for the GNU programming environment. They are separated by columns. Column here, and there's only one here. But if you're programming in Fortran, you will actually need a different syntax, because Fortran use -I and then the path. So this is another way of dealing with the environment or variables. Like you'll see here, this one will give you -I and the first include directory, then a blank, and then -I with the second in include variable. So you can just compile your program with this. Of course, that doesn't work because prog isn't needed. But this is how you could do that in an easy way. So, and I think it's 12 o'clock, so I think it conclude here, and
Yeah,
next time it will be advanced awk, and we run through the practical example, but you can easily do the practical examples and Slurm script as homework, because they
Yes.
copy paste.
Thank you so much, Ole. Can you share the collaborative document?
Yes, I can.
Great. Can you go down a bit further? Yes. So thank you so much, Ole, for giving this training, because this is the first time we are giving an advanced shell scripting and utilities, and we started from the scratch just before Christmas. So thank you for your hard work, and thank you for all your interest in our course. And I would like to emphasize, we are collecting feedback from you. Please give us feedback for the day. One good thing about today and one thing you would like us to improve next time. I just want to also mention that the later part of this course, which include advanced OP and set, and some more examples, that will be on 8th April. You can find the information on the course webpage that is linked on the collaborative document here, and it needs a separate registration. We also have another event in March, that's on containers on HPC. That's also need a separate registration. Each event of this best practices series need a separate registration. So one important thing, please give us feedback. This is very important for us to improve next time. And this course material will be maintained, and we will, based on your feedback, we will work on the course material also. So it's for everyone's good. You will, if we get the feedback. And I would like to thank Kim and Enrique for joining and helping us during this event. And this course is recorded, so I will be editing later today. And when it is published, you will get an email from me. Thank you. So